And welcome back, 30th of March, higher plus 5 a day, very nearly the end of the month. And let's just go straight with the first question. Right, what do we have? Now, having said yesterday, we haven't seen one of these for a while. We've got another quadratic sequence. So my pattern is, I'm going to start by working out this second difference. So I'm going to do that by looking at the difference between 11 and 12, which is 1. 12 to 15 is 3, and 15 to 20 is 5, which means my second difference is 2, because my differences go up by 2. Now, if my second difference is 2, that means my a is equal to 1. In other words, when I'm thinking about the nth term in my quadratic sequence, which is an squared plus bn plus c, my a term, this term here, is going to be 1. Next step. Now, I know what my sequence is. My sequence is 11, 12, 15, 20. And I know what my n squared bit is. My n squared, as we've just said, is 1 lot of n squared. So let's take that away and see what's left behind. So this is my first term, second term, third term, fourth term. So 1 squared is 1 times 1 is 1. 2 squared is 4, 3 squared is 9, and 4 squared is 16. Now, at this point, if I take it away, so 11 minus 1 is 10, 12 minus 4 is 8, 15 minus 9 is going to give me 6, and 20 minus 16 is going to be 4. If that is not a linear sequence, I've made an error, because it tells me it's a quadratic, so it must be the case that's true. Anyway, point is, I now have my linear sequence. I know the nth term of that is going to be minus 2n, because it goes down by 2, plus 12 to get me back to the first term, which means my nth term is going to be 1 lot of n squared from the a equals 1, plus, well, it's actually a minus, isn't it? So minus 2n plus 12. And that is that question done. Nice question, nice sort of straightforward theory type question. Next question. Okay, so quadratic inequality. We've got a quadratic, got an inequality, so it must be a quadratic inequality. The method here is I need my roots. Now I can factorize this as x minus 7x plus 3, 7 and 3, yeah, that's correct, is greater than 0, which means if I map this, that goes through minus 3 and 7, so the minus 3 from here and the 7 from here. And I want all values that are greater than 0. So in other words, I want all values where x is greater than 7 or x is less than minus 3. Question done. Next question. Prove, then it gives me a statement, is positive. Now, this is one of those things that you haven't seen this before. There's a very definite way of writing this. So I'm just going to expand everything. So that's going to give me 9n squared plus 12n plus n minus 6 all squared is n squared minus 12n plus 36. And let's collect the terms. So n and n squared is 10n squared. 12n minus 12n goes away. And that just leaves me with plus 36. Now, you don't need to explain why. You just need to make a convincing argument that you understand that this is greater than 0 for all, the upside down a means for all values for n. And maybe I'll write, just to show what I'm talking about, because squared. I don't think you need to write that, but just you're showing you understand that's always positive. Any number you ever have, if you square it, will always be a positive number. And 36 is obviously positive, so therefore positive, what does it say? Positive for all n. Just write as a little conclusion. It's good practice, less needed at GCSE, but good practice anyway. Next question. Right, what do we have? So straight line passes through D and E. Okay, so this is, I'm going to call that L1, because I think I know where this might be going. Find the equation of the line, and there we go, perpendicular line. Perpendicular to DE passing through F. So my perpendicular line is going to look something like this, isn't it? It's going to be perpendicular, and I'll call this L2. And that's it, so find the equation. Now, I'm going to find the equation of line DE first. I don't need the line, we're going to do it anyway, because I'll explain why it's simple. So the gradient is 10 to 1 is, so let's write m, is minus 9, and 0 to 5 is plus 5, so it's not a nice gradient, but my gradient is minus 9/5, which means the equation of L1 is y is equal to minus 9/5 x plus 10. And how did I know that? Well, the reason I knew that is because it tells me the y-intercept, so therefore it's quite easy, which is why I thought I'd write it down. Still haven't answered the question, have I? Because the question wants me the equation of the other line, L2. So L2 also, I know the intercept, and it tells me here that it's minus 6. So actually this isn't too bad at all, is it? It's just going to be y is equal to the negative reciprocal, which is 5/9, times by x, and then take away the c value, which is minus 6. So that's going to be 5/9 x minus 6. Great. Next and final question today. Find the shortest distance between the line passing through DE and the point F. Now, okay, the question's built this up nicely. It's about you understanding that the shortest distance between a line and a point is a line that is perpendicular to that line. In other words, I need a perpendicular line and I need that length. So what I'm going to have to do is I'm going to have to work out the intersection point M, and then I'm going to have to work out the distance from M to F. And of course, just quick aside, that makes sense because any other line must be longer because it's not at a right angle, it's at an angle, so it must be a longer distance. So I'm going to have to start by working out where, let's call this line 1, call this line 2, or L1 and L2. I need to work out where they meet. So I'm going to do, this is going to be really messy for the numbers. So minus 9/5 x plus 10 is equal to 5/9 x minus 6. Okay, now normally at this stage I'd multiply by 45, but let's just try and do it in one go. So bring my 6 to the sides, that gives me 16, so add 6 to both sides. Add 9/5 to both sides, so I've got 5/9 plus 9/5. Now you should be able to do that, but I'm going to just do that on my calculator. So I've got 5/9 plus 9/5, which actually then means that x is equal to 16 divided by 5/9 plus 9/5, 106/45 on the calculator, obviously, and this is definitely a calculator question. And then 16 divided by that is going to be 360/55. Wow, not a great number. I'm going to keep it as a fraction. I think if you're using rounded decimals, that would be fine, but I'm going to keep this as a fraction. I think that just might make it easier. Remember, I'm still trying to find the point M because I need my midpoint so I can work out the length M to F. So I'm still not done. I need to work out the value of y. I'm going to do this over here. So therefore y, and I'm going to use, just because it's above, I'm going to use this equation here. So y equals minus 9/5 times the x value, which is 360/53, and then add on 10. So put that in my calculator very carefully, and I get minus 118/53. Which means my M, my meeting point, is going to be 360/53. And well done if you're keeping up at this stage, minus 118/53. Now, let's just quickly catch up on what we've done. So what we've done is we've worked out the line L2, we've worked out the line of L1, we've worked out this meeting point here, which is the thing we've just done, M. And now I need to work out, because what am I doing? I'm working out the shortest distance between the line passing through DE and the point F. In other words, I need the length of M to F. Now I've got to be careful because it's even more complicated than it looks. So M in the X value moves across 360. So that's not too bad. So it's Pythagoras. So my X movement is 360/53 squared. And my Y movement, well, I'm at minus 118/53. And I want to move to minus 6, which is the F value. So it's going to be, let's do minus. So minus 118/53. Even if you just watch me do this, get your calculator out, check you can get the right answer here. It's very easy to mess that up with my calculator. So I'm going to do it now. And I get 7.7702868899. But I'm going to call that 7.77, doesn't ask for any accuracy. 7.77 hasn't given me any length, so I call that units. Wow, what a final question. That is a end of paperish difficult question. It's not the really, really hard one at the end, but that is a difficult question. So well done if you made your way through that. As ever, let me know how you did. Do like, subscribe. Let's go take a breather after that last question, and I'll see you tomorrow. Thanks all.